Hello everyone, my name is Felienne Hermans, and for a long time, maybe like a decade and a half, I've been spreading the vision that everyone needs to learn programming. Every adult, everyone in the workforce, but specifically kids. Young kids, maybe even toddlers, have to learn about the digital world. They have to understand how computers are not just something that beams YouTube videos into your eyeballs, but computers are magical machines that can turn you into a creator. So this is actually going really well, this story of everyone should learn programming, kids should learn programming, until like 2 years ago and GPT came along. And everyone's like, oh no, Felienne, no one needs to learn programming anymore because GPT can do programming. And initially I was like, I don't care, right? I don't care about this. You are wrong. I can just ignore you because you are wrong. But then after a while, you see that if people in the programming space, us programmers, if we say programming is no longer very useful, then soon also normal people that aren't programmers, right? Adults, teachers, people in the workforce that aren't programming, they will also start believing this story. So then I had to change from I don't care about this into, well, I have to do something with it, or this opinion will spread outside of programming as well. So I have to think like how to convince people that programming is still super useful in the age of GPT. So let's do some audience participation. Who in the audience has ever ran a marathon? Yeah, why, sir? Why?
Because I turned 40, so I need something.
Okay, so he turned 40, so he needed to do something. But why would you do a marathon, man? Cars exist. Like traveling 42 kilometers is a problem that has been solved by technology. Amply, right? Cars, buses. You can take a horse, you can take a metro. So why on earth would you do a marathon, right? It makes absolutely no sense at all. Well, because doing a marathon is, of course, not about traveling 42 kilometers. Doing a marathon is changing yourself from a person who hasn't done a marathon into a person that has done a marathon, right? That has suffered all the way through it. You're like at kilometer 30, you're like, oh, this is terrible. I'm going to just sit right here. No, I will continue. Oh. So that is what doing a marathon is about. Doing a marathon is about, for the rest of your life, you can bring up running marathons all the time, any birthday party, any conference talk. You're like, I once did a marathon in 3 hours 57. That's the goal of a marathon, right? Not to travel the distance. So that is also why programming is still very useful. Why programming education makes a lot of sense, because it turns kids from kids that have not done any programming, that have never been a creator in the digital space, into kids that have created something, even if it's something small, like even if you've done a 5K, that's still something you did. So I think that is very important to keep in mind, to talk of what is the goal of programming education. If we teach kids programming, what do we want to get out of this? And I think a lot of people, specifically us programmers, we think programming education is about taking kids that already know what programming is and turning them into someone that actually knows how to program. But I don't really think that is the goal, the true goal of programming education. For me, it's much more about taking kids that really don't know what programming is, that have no clue what programming could bring them, and turning those kids into kids that have some sense of what programming is, right? And I know this is super abstract, so maybe you're like, what is the difference between knowing what programming is and knowing how to program? So let's do another mandatory audience participation moment. Who of you in the audience has ever made clothes that they also wore outside the house? Yeah, quite a bunch of you. So everyone that didn't raise their hands, right? You are not just a person who never made clothes. You are more a person that probably never even considered to make clothes. I'm pretty sure that people that have never made their own clothes, they don't go to a shop. It's like, oh, I want to have a blue sweater. Oh, there's no blue sweater in this shop. Next shop. Oh, there's no blue sweater here. Oh, there's no blue sweater here also. Okay, I will make one, right? It doesn't even consider, like you don't even know how to start, right? Because you don't know what making clothes, what it means. Are you going to sew or knit or crochet? What tools do you need? You could actually get all this knowledge from YouTube. You know that, right? You know that this is something that some people do. But you don't consider it. You don't consider starting it in any way because you don't know. And I think that is really very much these three things as well. A lot of people, kids, but also people that just haven't been exposed to programming, they don't know what programming is, much like you don't know what making clothes means. So they don't have an interest in learning how to do programming because they have no conception of what it is and what it brings. So I think it's much more important that we focus on getting people into the state that they're like, oh, programming, well, that means controlling a computer, and maybe that means creating this, like a little game or a website. Get people to understand what it is, and from there, they can learn, of course, like you can learn making clothes with all sorts of books and tutorials and workshops. So, just to conclude, yes, everyone still needs programming skills, also in the age of GPT, maybe even more so, because there's so much talk about what AI can and cannot do, that if we don't get a lot of people into the state where they understand what programming can do, they will say very real things like the robots are here to kill us and P-Doom is one. So it's very good that a lot of people can participate in this conversation. So I really believe that all kids should learn programming to such an extent that about 10 years ago I started to teach in a middle school. So I started to teach 12-year-olds programming because, I mean, the nice story that makes me look good is like, oh, I want to do service for society and teach kids. I mean, the real story is I had a job in a university that I didn't like, and I was escaping to this job that sounded fun. Teaching 12-year-olds sounded a lot more fun than working in the university. So I thought, this is going to be great. I'm going to teach children programming. And then I know a lot about programming because I have a PhD in software engineering. And then the kids, they will sit in silence and they will ask me questions. And because I know so much about programming, I will answer the questions. They will be impressed. And then at the end, they will know programming. And everyone will be happy. Shows how little I knew about teaching. But what happened is, subconsciously, I remembered my own childhood. So this is me when I was about 10. Learning programming, sitting behind my dad's really big computer. But when I was a kid, I didn't have programming lessons, because I didn't know any adults that also knew programming, so no one could teach me programming. But I had a book from the library, and this was a book that was going to help me make computer games, which was good because there was no Steam, no internet, I didn't have a PlayStation, maybe PlayStations weren't even invented yet, so I wanted to have games on my computer. But this book, you shouldn't imagine this as a book that says, this is a variable, and this is a loop, and this is how you create a program. If you would open these books, they would look like this. And then younger people in the audience might be like, well, Felienne, wasn't there a download link? Or a CD-ROM, maybe? Or a diskette? No, all those things weren't there. You had to manually copy these listings into the computer to get the computer games. But I wanted a computer game, so I was going for it. And sometimes, of course, stuff went wrong, and then the computer would say syntax error. Or it would say expected, colon, comma, semicolon, or end of statement. I didn't know any of this, what this meant, specifically because I didn't know any English. So I had no clue at all what this was saying. But again, there was no internet, right? So I also was not distracted by TikTok or YouTube or whatever. So like, I want a game. This will get me a game. And this isn't just me, right? I see a lot of people nodding in the audience. You know that the people that are nodding are like 40 plus, like me, because this is my generation. A lot of people learn programming this way. And that means that in our collective memory, a programming lesson means learning by yourself from a book and not being in a classroom. And I'm not a very big fan of GPT or other AI systems, but what they do really well is visualize collective memories. So if you ask an algorithm to show you a picture of a hacker before they started learning anything, you can really see visually what people apparently think because this is the image. And this is so interesting, like, it's a white boy, there we can start. But I think what's much more interesting is that this has the word learning, and yet you don't see a classroom. Because this is what we think learning to be a hacker or learning to be a programmer means. You do this in your own bedroom, and you're such a fan of computing that you have your CD-ROMs on the wall. This is your hobby, this is your sole hobby, right? So I think this really nicely shows what we think is learning to program, and this is very much what I thought when I was starting to teach 12-year-olds. But those people that you saw nodding in the audience, we have maybe acquired some mental damage, some trauma from the way we learned programming. Specifically, we think that compilers are great teachers. Because we didn't have any other teachers, right? It's like if you only have one toy, then it's like, oh, this is my favorite toy. You know, it is a teddy bear. And it's not a teddy bear, it's just a plastic bag with 2 eyes on it. But you're like, I love him, he's fantastic. This is how we feel about compilers, right? Compiler is my friend. It taught me programming. It is my bestie forever. No, this is trauma speaking. This is not good. But I didn't know all these things when I started to teach programming. I really thought that this is a really good way to learn programming. It's just to give kids printed out Python code or Scratch code and have them try it, because it worked for me. It worked for all of my friends that are also programmers, so I didn't know any better. And to give you a little bit of context on what we did in the club, initially we started with a programming language called Scratch. Who's seen Scratch or worked with Scratch? Yeah, quite a bunch of you. So it's a visual language, like Lego blocks connected together. And initially, this actually worked really great, because Scratch does not yell syntax error at you. So it goes quite well. But then after a while, the 12-year-olds, the 13-year-olds were like, well, this is for kids, right? This is a toy language. It has all these colors. We want to have a grown-up language, teacher. So I was like, no problem, kids. We'll go to Python. Python is an easy-to-learn, super user-friendly programming language. So this is Python. Here you go. We're going to print code on a screen. So you have to put print there and brackets and round brackets, quotation marks. Very important that you get all these things right. And the kids are like, wow. And then if we do this, have we built Minecraft? I'm like, nah, you get that text on the screen. So that was already a problem, because when I was 10, text on the screen, everything was text on the screen, right? This was before Windows. Text on the screen is just what a computer does. But these kids were like, nah, okay. But you know, we asked for the adult stuff, so let's go for it. But of course, sometimes they made some mistakes, like putting an uppercase P in the word print. Reasonable, right? Sentences start with uppercase letters in many languages. And then, does Python get this? No, of course not. Name error, name print is not defined. And much like when I was 10 or 11, these Dutch kids, they don't really know English. So this error message is quite incomprehensible, even if you know a few words, like defined in my native language would be gedefinieerd. So it's somewhat similar, but it's still quite a high threshold. And also notice how the red letters are shouting at you. So the trauma people like me, they're like, yeah, that looks like an error message. But the other people are like, it's red. This is scary, I broke the computer. But it gets worse, of course. Here, I accidentally forgot a bracket. Syntax error, unexpected EOF while parsing. Teacher, what is parsing? I'm like, don't worry, kid, I have the dragon book right here. But then, not all 11-year-olds are interested to know what parsing is. And it's like, I don't want to talk about parsing now, right? I don't want to talk about what is parsing in the first lesson, because that's just going to mess with your head. Okay, after a while, some kids are already like dropping out, but there's one kid who's like, teacher, I had everything. It has no capital letters, brackets are there, the quotation marks are there. This is perfect. Oh, but it isn't, because it's Python, right? This is a space. This is literally an invisible mistake. And what does Python say? Oh, buddy, I got you. I know what you mean. No, Python says indentation error, unexpected indent. Teacher, what is an indent, right? I don't want to talk about that now. So at the end of the school year, not so many kids were still excited about taking my programming course. Almost all of the kids were like, yeah, we go do something else with our elective choices in the school. And there were some kids that actually stayed in the club. And initially I thought, I deluded myself, right? I thought, I cannot be such a bad teacher because there are still some kids that do like programming and they chose this. But then upon a little bit further reflection, those were almost always the kids that were already excited about programming, right? They came to the class, they're like, I want to learn programming. And then we like threw all these red arrows at them and they're like, I still want to learn programming. This is the best. So I hadn't really made a big impactful change because those kids were going to do programming anyway, right? It had nothing to do with my teaching. And what I also realized after a while is that the kids that were dropping out of my class were almost always girls. I thought, this is interesting, right? Why would that be? And I think it has a lot to do with the self-image that girls come into programming class with, right? So girls already hear, if they're 12, programming is hard. Programming is not for you. You know, sometimes I have dads bring their girls into the programming lesson and they're like, yeah, is this actually going to be fun for my girl? Because I work in IT and I don't have any female colleagues, so I don't know if this is for her. Right? Don't say these things. So girls have this self-image that computing is hard and that is not for them. Imagine that's how you're feeling. Like, I don't know if I like this. I think this maybe is going to be really hard. And then the first thing that you see is unexpected EOF while parsing. So that's going to really drive the message home that programming is hard, right? So girls have this low self-confidence, not because of nature, but just because of society. And then an error message really hits differently if you're already self-conscious than if you're like, ooh, programming, I can do this. Then maybe you don't care so much. And I think we don't talk about that aspect of inclusion all that much, right? We talk about open discrimination and women in tech groups and quota, but we never really talk about the usability of error messages as being an inclusivity problem. But I saw in my classroom that it very much is. So then I got somewhat nerd sniped. I already mentioned that my current job that I was having, I didn't really like it, so I was happy to be distracted by something. So I thought, all these kids are not excited, they're also not really learning. Why, right? And in the meantime, I had convinced myself that it was about me, right? Because these kids, they could do Dutch and math and English and German and French and geography in school. So then they were smart, right? So why couldn't they learn programming? And I started to learn a lot about learning. And I realized if you're a computer science student, you never learn anything about learning. Not in the university system, also usually not in boot camps. We always say, oh, if you're a professional programmer, you will learn many other programming languages. But we never give kids tools how to learn, or students. So I didn't know anything about learning. But together with someone from the psychology department, I actually learned a lot about learning, specifically about natural language acquisition. How do kids learn natural language, writing their first language? So imagine you have a 5 or 6-year-old that writes this. How would you respond as a teacher? Would you say, error, unexpected floating I? And we don't do that, right? Why? Because it's very, very discouraging. If your 5-year-old does this, you're like, well done, buddy. Most of these things are letters. Keep going. And then after a while, we're like, oh, you know all the letters, which may be 26 in my case. Great. You can use them to make words. And it's like, wow, words. And I go like, cats, cat in tree. Yes. You don't go like, where's the article? Right? No, you're like, yes, well done. And then after a while, you're adding articles. And then you're adding rules also. Like every sentence should end with a full stop. And then this is not just adding syntax, it's also adding expressive power, because once a sentence ends in a full stop, you can make sentences that are longer than a line. Wow, cool. So you do this gradually, step by step, and you don't immediately catch kids in a small syntax error if they are just learning. So then I thought, what an interesting idea. Encouraging, right? And having rules that are very soft in the beginning, and then making the rules stricter as we add programming concepts. I have a PhD in software engineering. I took 5 compiler courses when I was in university. I could make a programming language that also works like this. So I did. And that's what became the Hedy programming language. So this is, here you see Hedy. This is level 1. So like with the natural language syntax, we slowly, gradually build up the rules. So in the first level, you just do print, and then you do hello, and that works. No brackets, no quotes, no fluffy stuff, just the basics. And then, as I said, kids were not so interested or excited about just having text. So from the first level, we show that you can make user interaction with programming. So we have two other concepts in level 1, ask and echo. And ask asks the user a question. Hey, how are you? And then echo repeats this answer back to the user. So you are great. And this helps alleviate the comment that some kids had. They said, yeah, why would I do print hello world? I can just open Word and type hello world there, right? So I want to show, look, a computer is something you create a program and there's a user that uses your program and you can have interaction. This is level 2. Oh, I should have said trigger warning. Trigger warning. This is level 2. So in level 2, we introduce variables. But you can mix variables with strings. So this code actually executes. Name is Felienne, print hello name. This works. So you're all like, no, but the one is a variable, and the other one is a plain text string. But this is confusing. Yes, this is confusing to you. But for kids, this is not confusing at all. This is just how it works, right? You store values, and then you use the values. And technically, this is also not so hard, because we just parse the program twice. And just as a reminder, if you want to do something like this in Python, you would have to do all this syntax. And for some kids, they never really break through the syntax barrier. So if they have to do something like this, ultimately they get it right by putting the commas and the quotes and the brackets there, but they haven't really understood what I was trying to tell them. Whereas in our version, you can really focus on the concept. The concept is we put something in the computer, and later, if we want to, we can retrieve the concept back. You don't have to do all the complicated syntax. So this is level 4, and in level 4 we add quotation marks, because ultimately we are building up to something, we are building up to Python, so you have to learn this rule as well. But then if you make a mistake, if you accidentally forget a quotation mark, we have reasonable error messages, right? Oh, if you ask or print something, you have to put quotes there, and you forgot that there. So it's very precise, it highlights it in the actual text, and this is helpful if you make a small mistake. And then, as I mentioned, slowly we go towards Python. So level 18 of Hedy is a functioning subset of Python that has loops and lists and functions. So from there, kids can like go away and do other things in Python, because we help them bring to Python in what we call like a reasonable way. And from there, you can do all your other learning. So I just said like, oh, I made a programming language, but let's zoom into that a little bit. Like, how do you make a programming language? Well, it's not so hard actually. There's a lot of libraries that you can use. And there are two parts of building a programming language that are important. And this is also somewhat similar to natural languages. So if you're reading a sentence, then what you would do if you're a 6-year-old or if you're reading an unfamiliar language is you read every letter, like k, at, f, oot. And then you parse it into words, and then you're like, oh, I know what a cat is, I know what a food is, I can understand this. So those two parts also exist in programming language design, where this part is called the syntax. So in Hedy, this is actual Hedy syntax. So you have print hello, and you also have turn. We use this for a drawing turtle. And then this is our syntax. So we say, well, you have the keyword print, and that's followed by letters, and you have the keyword turn, and that's followed by digits. And this is called a grammar usually. And a computer actually really reads like a 5-year-old. So they go like I-N-T. Ah, okay. And what I expect now is letters. Are there letters? Yes. Great. And here the same. You get the keywords, and then you know, oh, this is turn, and then afterwards come numbers. Okay, are these numbers? Yes. Great. So this is correct syntax. And sometimes, of course, kids also make mistakes. So if you do this program, it's sort of a reasonable program where you have turn, and then you put the word 10 instead of 10, the numbers. So this works, but then here the compiler gets upset because it was expecting a number, but it got a letter. So this is incorrect. And if you know this, then you also understand better why programming languages errors are the way they are. Because it really goes letter by letter. And then if you get the wrong syntax, the unexpected end of file, then the parser is going to get confused. And then the second part is the meaning, or that we call in computer lingo often semantics. So if you know what is there, then you can think, okay, how does the computer execute this? What does it mean to do print forward? And there's some different ways that you can do this. Some semantics are expressed as a compiler, so that turns a program into binary code. So let's say zeros and ones. That is not what Hedy does. We do it somewhat easier because Hedy is already so close to Python. We just translate the Hedy code to Python, and then we can execute the Python. So that is somewhat easy. So what I realized is that this is also a very interesting technical challenge, because most programming language design tools are created for one programming language. Like there's one Java or one Python. But in our situation, we have many different syntaxes. All of our level have a different syntax. And also very often we add concepts, so we also get a different semantics. So then we need 18 syntaxes and 18 semantics and 18 interpreters. So it's quite complicated from a technical standpoint. And that was fun because I thought, oh, accidentally I created a complex technical problem where I was just trying to build a simple programming language. And even though there's a lot of research on programming language building systems, no one had ever had this specific scenario where you want to have 18 slightly different grammars. So then this turned into my research project, right? I was trying to escape my university job, but then I sort of came back because we're like, hey, I'm solving a nice technical challenge. This is good. This is university work. And the university was like, well, it's for kids, so we're not super excited, but you know, you're writing paper, so yay. But my actual goal was not to do research. That was just to keep my employer happy. My actual goal was to try this with kids in the school. So when I built the first prototype, this is early 2020, I started to try the prototype with 12-year-olds in my school. It's like, yeah, let's do Hedy. And one of the most interesting results I think that we initially already found is that in the old days, when we were doing Python, I was running around like crazy, right? Imagine 30 12-year-olds all behind the computer, and they all get error messages. So even if you're an experienced programmer, figuring out how they made a mistake, especially if it's weird syntax, is really very energy consuming. So it's like, oh no, unexpected syntax. Then I had to read the error message, and I had to then look at the program. Oh no, oh, indentation error. Probably it's a space somewhere. And then I mean, like 20 other kids are also confused, taking each other's jackets, you know, throwing their backpacks. It just gets really chaotic. And then when we switched to Hedy, it was like, this is nice. They're not so confused anymore, right? And of course, some of them still got error messages, but it was a lot easier for me, the teacher, to understand the error messages. And I could also say, if an error message popped up, I could say, hey, you are missing a bracket on line 4. If you would just read the error message, I think it actually tells you what to do. Whereas if the error message is syntax error unexpected EOF, I cannot say, read this error message again, Dutch child. It tells you what to do. It tells me what to do, but for you, this is just magic, right? This makes no sense. So I was happy. So I said, hey kids, what do you think of this super cool new programming language? Any feedback? And one kid is like, yeah, I don't like your error messages. So it's like, wow, that doesn't seem very grateful. Like, have you seen Python? Have you seen C++? Like, so it's like, okay. Tell me what is a problem. So the kid says, this is a problem, teacher. This is a problem because this is a very weird error message. So I thought this kid is just not reading the error message, right? It's really good. It tells you exactly what the problem is, and it also tells you exactly where the problem is. How, child, is this not clear to you? Read this error message to me. So the child goes, yes, a mistake on line 1, position 12. You typed, but that is not allowed. You typed, but that is not allowed. Why can't I type? I'm typing all the time. Like, what have we told 12-year-olds for like 5 years? If you see a comma, you take a little break. You typed, but that is not allowed. And this is so funny. This is the stuff you can only get from sitting next to your users, right? I could have easily found in the database that this was not an error message that led to a lot of success. But this kid is like, you typed. Wow, thank you, I'm an idiot. I will go cry in the bathroom while you continue programming, right? So this is our error messages as they are now. So all of the words we've actually vocalized out. You typed a comma, but that is not allowed. And what's interesting, if you work with this system for a while, then even though I'm a professional programmer with 30 years of programming experience, I actually also like this. I would also like other programming languages. If there's any language designers in the audience, I would like this. It just takes me less energy to read this, to read a word. It goes quicker than to parse this, that also has not just the comma, but also the quotes around the comma. So 12-year-olds are maybe just a really good audience for improvement. But what I also saw, not in my classroom, but specifically in other classrooms in my school, that the kids were excited, but they didn't know what to do. Right? So we just said, oh, here's print, here's turn, here's forward. You can make stories or drawings. And then what I remembered from my childhood is like, I immediately had ideas. I was like, oh, I'll make this story and I'll make this drawing. And I had friends in school that were also programming and we exchanged exercises with each other. But the kids were like, I don't know what to do. And the teacher, not being a professional programmer, but being a teacher, was like, yeah, I also don't know what to do, right? And then, of course, they came to me and I gave them ideas, but I thought this whole wealth of ideas in my head isn't in the system. And this, again, is about gender, right? I hate to bring it to you, but many things are about gender that we haven't thought about. Because what type of kids like exploring? What type of kids like free-form exercise that do not tell you when you're done? We just know from research that boys are much more likely to like exploration, and that girls are much more likely to actually want to have clear goals that they can achieve. And maybe this is related to this self-confidence issue that I talked about before, that if you're like not sure if you're good at programming, and there's no finished state, how will you get confidence? Whereas if you do an exercise and you get it correctly and you get a point or a star, then you're like, I did it, next exercise. So something like free play and exploratory learning, it's much more appealing to people with confidence, which are much more often boys or kids that come from a family where someone is also helping them on the computer. And if you know that, and if you then look at the user interface of programming systems, this is Replit, an IDE in the browser that is used for teaching a lot, and this is Scratch, of course. If you look at those things, they don't look boyish. They don't have robots and soccer balls or whatever is in your culture typically seen as something for boys. But if you know how boys and girls like to learn, you look at this, and you're like, this is meant for someone who has a goal in themselves. This is not meant for someone who doesn't have a goal yet, which again is so much more likely to be a girl or a kid from a low socioeconomic background family where there's no computers. So this is Hedy as we have it now. So in every level, we don't just have one exercise. We have all these different exercises that tell you what to do. This is the print command. This is the exercise. Take this example program and fill it with your own ideas. And then as a teacher, you can tick it off as well. You're like, yes, well done, next exercise. And this helps in confidence building. And then we have to go back to this story that I talked about earlier in my talk, that if you don't know what to do, then you really need to be told. If someone in the audience is now like, yeah, I want to make my own clothes, you need to get help from someone just to get the difference between crocheting and sewing and knitting to know what to Google for, right? So this stage is where explanation matters most. We get kids that don't know what programming is, and I tell them, programming is what helps you create a drawing or a story or a little app or a little program. This is what matters. And this is what teaching is, right? This is where you have to explain something. Whereas here, learning can happen. And not, I don't know about Danish, but in the Netherlands, learning and teaching can also be the same words. But in English, it's very nice. Teaching is different from learning. And I think that is maybe the most important lesson that I learned in building Hedy, that tools that are meant for teaching aren't the same as tools that are meant for learning. And because of this collective history that I talked about earlier in my talk, because the only thing that has ever taught us anything was ourselves, many people that are now programmers don't really understand the difference between teaching and learning. And therefore most of the tools, and I think this really also includes tools like Scratch that are so open-ended, are tools for learning. They're tools made for one individual consumer, the child, and to not like lessen their enthusiasm by allowing them everything. But if you have kids that don't know what to do, you absolutely need teaching. Tools for teaching bring kids there, and tools for learning get kids farther away. One more thing that I saw in the exercises that we were doing in the school, both in my own classroom and also in other classrooms, is that there's such a big skill difference in between all the kids in the classroom, right? You have kids, they're like, oh, teacher, I made one block. What do I do now, right? And in the same classroom, there's also this kid. Teacher, I made this, but I want the palm tree to be blue and not green. How do I do this? Fuck if I know, right? I have no clue. But aren't you like a professor of programming? I don't know, man. But then you have to also help these kids. Well, you don't have to, but of course they also have these questions. And it's so energy consuming as a teacher to manage all these different programs at all these different skill levels. So what we have in Hedy now is the ability to make teachers' lives easier by blocking off access to certain content. So if you're a teacher, you can see now that not all of the tabs are enabled, but just a few of the worksheets. And then I can also, as a teacher, add my own content. So this is like, if it's Santa Claus in December, I can add an extra exercise only for my classroom. And as I said, you can also block off levels. Just like level 1 is what we're doing today. And if you're at the end, you are done, right? Go read a comic book or a book or do your German homework. You are not my problem now, right? My problem is to get everyone to your level. And again, for sometimes people get upset with me for saying this. They come to me after my talk. Yes, but I'm like, but what about kids that are so excited? And aren't you like stopping their excitement? And like one answer is, do you remember yourself as a 12-year-old? Is there any stopping excitement about programming? So no. And also, even if that would be the results, right? For me, that is a price I'm willing to pay. If I get a few kids in the beginning of the year, again, which are often girls, they're like, programming, I don't think this will be fun. I don't think I can do this, teacher. And I get them to the point where it's like, wow, look, I made a star, right? Then if that's maybe detrimental to some enthusiasm of some students, like, that's okay, right? You cannot help everyone. And if we only care about the kids that are excited already, then what are you in a school for? So there was one more thing that kids told me in this experiment. It's like, okay, I dealt with the error message. What else? And the kids were like, we would like to please program in Dutch. It's like, why? Why do you want to program in Dutch, right? Programming is fine. Everyone learns English. This is fine, right? And also, if we start to program in different languages, then this will be hard because some people will program in Swedish and other people will program in Turkish, and then they cannot speak to each other. So initially, my reaction was not, yes, this is great, right? I don't want to retcon this into, I was immediately convinced. I thought, no, this is not necessary. They can just learn some English words. But I got nerd sniped, right? Again, I was like, oh, but now I'm curious if I can build this. I'm a bad person. I will just openly say it. I was not like, I'll do this for the kids. I was like, I'll do this for the technical challenge. This will be cool to build. And now that you know how to build a programming language, you can understand it is not so very hard to actually change it. You can take turn and you can just turn it into draai in Dutch, and then it is Dutch. It's relatively easy. And the minute we added this feature, Hedy exploded. Like within a few months, we were at like 20 different languages, German and French and Spanish and Portuguese. And then I started to see, this is actually useful. This makes people happy to program in their own language. So I did something very dangerous. I started to feel really good about myself. I thought, oh, look at me. I made a programming language in so many languages. This is awesome. Don't do this. Don't do this. This is dangerous. Because then you have friends in your life. I have a friend, Aladdin. He's from Palestine. And he's like, so, Hermans, so impressive. These left to right languages in the Latin alphabet. Well done, you. What about Arabic? It's like, come on, man. And Chinese, yes, yeah, many languages. But then I started to talk about it. Imagine you're teaching, right, in Yemen or in Palestine, and you're like, welcome to programming class. The first word that we're learning is print. It starts with a P. And the kids are like, what is a P? How is a P different from a B and a D? It's the same thing. Oh, there's also a Q, it's a P, but reversed, like right? So there's such a threshold just in communicating about the letters only. So I thought, yeah, Aladdin, you are right. This is a lot easier to learn. And then he added a new perspective that I actually didn't think about. He said, it's not just about learnability, it's also about usability. Because if you want to use strings in Arabic, which of course you want to do, right? You want to do print marhaba, which is hello, then you have to switch keyboards. You have to first go to Latin keyboard to type print. Then you have to press a button or click with your mouse. And then you have to go to the Arabic keyboard to type marhaban, which is super annoying. Because you have to switch from the one keyboard to the other keyboard. And if you have a mildly bigger program, if you want to do something like, if your name is Hedy, then print awesome, you have to do all these different keyboard switches. And I hadn't thought of this ergonomic argument, but I thought, yes, this makes so much sense. If you have your keywords in your own language, you can stay within one keyboard setting. And this is, I think, actually a really, really good argument to use localized keywords in any programming language, because I'm sure many of you, if they program in Danish, sometimes use Danish words. If you work for a Danish customer, your ubiquitous language might contain Danish words. So then you have to switch between the keyboards with all the things. I don't know your letters, but the letters with the circles and the stripes and whatever, that's a hassle, right? You don't want to do this. You want to stay within one keyboard. So we changed that also in the grammar. It's not so hard to change it. And I was like, yes, we have Arabic keywords. It's like, hey, Aladdin, you know what I built? I built an Arabic programming language. Look, you can use it even in the turtle, so you can go like forward and you can turn. This is really cool. But he was not impressed. Again, I was feeling good about myself. Don't do it. He's like, that's nice. Now, can we add Arabic numerals? So I was like, what do you mean? This is Arabic numerals, yeah? They're called Arabic numerals. Please, person that is actually Arabic, tell me how I am wrong. It's like, that's not Arabic numerals. These are Arabic numerals that people use in some, or not all, but some Arabic-speaking countries. So it's like, I didn't know this. I didn't know this. And then you could be like, yes, Hermans, educate yourself. How did you not know this? Fair. This is on me. But also, how do I not know this, right? I went to elementary school in the Netherlands, and it is mandatory in Dutch education system to know Roman numerals. So you can converse with clocks and buildings. No one told me this. I took 5 compiler courses in university. Digits, 0 to 9. Always, right? No one tells you about this. So, of course, partly this is on me, but partly this is also, how do I not know this? This is the difference between learning and teaching again. I could have learned this, but someone needed to teach me that I didn't know. And then I was like, Arabic numerals. Do they work in programming languages? So we can try this in Python. Oh, 2 plus 9. Oh, invalid character. Oh, just this numeral that I've been using all my life in our entire culture, invalid character, right? And that's deep. There's this philosopher called Miranda Fricker, and she calls this epistemic injustice. Epistemic is the knowledge of knowledge. And this is the injustice of not being allowed to participate in knowledge creation, right? We often say a programming language is a representation of knowledge. And then maybe you're like, yeah, that's Python. But I tried in the whole TIOBE top 10 whether there's any of them that actually supports numerals in Arabic. This is C, this is C++, this is Java, this is C#, this is JavaScript, this is Visual Basic, the build failed, fix the build and try again, okay. This is PHP. PHP is nice. It says, oh, I don't know what you mean. I converted it into a string for you. And then it still failed. This is SQL. I had my hopes up for SQL. I thought, it's a language for data processing. Maybe sometimes data isn't not English. No, it also fails. This is assembly. It took me 3 hours to create an assembly program with Roman numerals just to add 2 things, because I, of course, forgot how to use assembly. But then I was happy because I was not happy because it still didn't work. Hedy, though, does allow this. Look, It just does it. You can just print 2 plus 9, and then you get 11. And you can also use it in a for loop. You can use a counter, like for I in range 1 to, that's not 0, that is 5. I mean, it's like, are they messing with me? No, that is just Hamza, it's 5. 1, 2, 3, 4, 5. It just works, right? So that is awesome. So from this very, very small prototype, this very small thing that I really just built for my own classroom, Hedy has turned into a massive open source project. We currently support 57 different languages, including also Chinese, Korean, Japanese. I used to be able to like enumerate all of them, but I don't even know. So it has really turned into this really, really big project that a lot of people use. So I really encourage all of you to check it out, hedy.org. If there's languages that you know but that aren't there, please feel free to add languages. We always love getting more content, and we are an open source project. So if people want to participate as developers, please go to hedy.org/join, where you can find information on how to become a translator, how to become a developer, or how to help us bring Hedy to more schools. The end. Yeah.